Hello lovely people. Today is going to be a second stage of this passive system. So I do apologize if the naming of this video was a bit confusing, because we're not going to have a head unit. What we're going to have is this DSP amplifier. I'm going to use it as a DSP. We're going to try to tune it like a second stage. 2 weeks ago, I published a video how to tune a fully passive system, and we treated the DSP as a source with absolutely no adjustability, just like the level and the tone control and nothing else. Everything was ran through this amplifier and into the passive crossovers. So if you want to go back 2 weeks ago and watch that video, just a reminder, I have, you're not going to see, a 3-way Alpine stator system and an upfront subwoofer as well. So today what we're going to do, I did swap out this DSP because after the testing, the Alpine and this recoil were complete opposites. So the Alpine was a quality one and this one performed the worst out of the bunch. And I swapped it just for the sake of reason, just to listen to it and see, can I really hear the difference between the Alpine and this one. So I literally just swapped it out, and the best part of swapping these DSP amplifiers is just because it has only one plug, just there, and 4 wires. And like, if you don't use the high level outputs, it's literally 4 RCAs and the plug. Take it out, put it back in. So it took me longer to remove the panels, the trim panels, than to actually swap the DSP, which is very, very cool. So this time, oh, by the way, after the last video, when I published, I got one comment that one guy said that he stopped watching my video when I took out the microphone because nobody can afford that kind of stuff and it's too expensive, and he was expecting something, I don't know, to be honest, what he expected. So just to clarify, I am tuning with a microphone, with a measuring microphone, and this one is going to be more in-depth tuning because I will keep everything passive crossovers on the front. So with this DSP, what I'm going to do, I'm going to be using EQ and time alignment, but EQ I'm going to use only graphical, the whatever it's called, not parametric. So basically this is going to be a substitute for a basic head unit that has some tuning capabilities, because most head units, even the cheap ones, will come with like 31 band of graphical EQ and time alignment. And this is what we're going to do. We're going to time align the passive front end with the subwoofer, and we're going to try to use the EQ only on graphical, not parametric. So I will be tied to the specific bands and to the specific Q of each EQ band. I won't be able to adjust those and see how it's going to go. So this is going to be like a basic head unit. Now for the last video, I did use my measuring microphone. For this one, I will be using the microphone as well, heads up. So if for somebody thinks that it's too expensive or is too difficult, I have a video all about you need to know about microphones, and in that state that to start measuring, all you need is like a mic for 30 like dollars or something, Dayton IMM6, and an external sound card, which is like just a few dollars. So like for $40 you can tune exactly the same as I do, because REW on the laptop is free. You don't have to pay for it. However, for this one, since I will be time aligning everything, I need to measure the impulse response. So for this one, I will be using a Scarlett audio interface and my XLR microphone, because I need the loop back and I need to measure the phase, because I need to try at least to phase align the subwoofer with the front end. So yeah, I think I said everything that I wanted to say. Now I'm gonna bring the laptop, bring all the microphones, try to tune it, and I'm gonna present you with the results. This tune in total took me about 2 hours, something like that, and it's mainly because I found something new that I would like to share with you as well, how to use the graphical EQ. So let me show you this. Like, this is the DSP software, the recoil, but like all the other will have something similar, and even head units will have something similar in the EQ section. So in this case, we can switch between parametric and graphical. So if I switch it basically from parametrical to graphic, what it does, it fixes the, like FC, the central frequency is fixed. I cannot change anything, and it's just the bands. The Q is fixed to 4.32. Sometimes I think it's 4.4, 4.5, it depends, but something like this. And the only thing that you can change is the gain, up and down, plus and minus, and you cannot change anything else. So this is a limitation of even some DSPs nowadays. I do believe some older Audisons do this. I think, I'm not sure about the audio control. I think they changed it to parametric, but they have like graphical as well. So like some DSPs have it still graphical, but all the head units, older ones as well, have graphical EQ. So I think it's going to be very, very useful. So this is limiting. However, I found a way, and I'm going to show you a way how to not guess, but actually do this with REW. So let me show you what I did, and I'm going to show you how I did it. So I took the response. Now, what I did from the previous, the 2 weeks ago, the tune, what I had, when I did it, I managed this bottom end of the passive system with a crossover on the amplifier itself. However, now I let the drivers run all the way down, so I bypassed the high pass and low pass, and I set the crossovers with the DSP. So basically this is left and right without any with nothing, just raw response. So we see we have a big mountain here on the left side because I have that in the kick, which looks nice. This is a dip, as I mentioned from the previous tuning session, that I think that is caused by the time difference between the mid bass and the mid range. So that's the left one, and on the right one, kind of the same, a bit less gain on the bottom end, and kind of there's a dip as well, but something like that. So this is left and right. Obviously, they're not level matched, nothing, it's just raw responses. And this is the Dayton subwoofer. So the subwoofer, you can see it plays all the way, and it plays up to like something like 150, 160, and then it goes down. There's a hole. Now, the thing that I saw, and probably you see here, for the subwoofer here and the lower frequencies, you have all of this jagged, very, very jagged response. And the thing is, when I was measuring this with the Alpine DSP, this wasn't there. It was much smoother response, and even like with the mid bass, you can see some jaggedness here at about 100 hertz, and on the right one as well at about this frequency, and like the bottom end is very jagged. So this is, I think, is down to the DSP itself, the recoil, because when I measure the recoil, I did say that it has like noise issues and problems at the very bottom end below like 100 hertz, because the noise floor and distortion went up in the lower frequencies. So I think it's caused because of that. And I will come back to this when I'm going to give my impressions about this whole system. So let's have a look what I did and how I did it. Oh, so crossovers. I chose just randomly 80 hertz acoustical crossover, because that's where usually we cross it. So these are my targets: subwoofer, this, and the overall. There we go. So just a rising bottom end from like 200 hertz, quite a lot. Down to 30 we have 75, 85, like 15 dB or something like that, and it's crossed at 80. So that's like this. So now what I need to do is make sure that my left and right are kind of following this curve. So I did apply crossovers, and I crossed them at 70 hertz Linkwitz-Riley or Butterworth 18 dB slope, and it gave me like something very, very nice. So let's have a look. Left one. Okay, so this is after EQ. So let me show how I did the actual EQ after the crossovers. So I set the crossovers first, and then which one? And then I loaded the mid-bass house curve here. And let's take number 2, which is this one, EQ. There we go. Okay, so this is like the most important part that I'm going to show you how I did this. Let me just remove everything. Yes, remove everything, please. Okay, so we have this response. From this response, I'm going to set the target a bit lower. This is, yeah, full or none, doesn't matter. A bit lower, so the target is going to be something like this. So like I could cut some, I could boost some. I'm losing a lot on the mid bass, but it's just the way it is. You cannot do anything about it because like the tweeter level is not there and the mid range is not there, and we have a few cancellations. So I need to match this to this. Usually what you would do, you would choose a generic DSP filters. You set the filters from, let's say, like 40 hertz. So this is what we usually do, from 40 hertz up to 40, let's say 14K. Then we choose 1 dB flatness target, and we match response to target. So this is with parametric, yeah? And basically we get this. So like if I remove this, yeah, we have something like this. So we use 20 bands of EQ, and these are parametric. However, with this, I decided to use graphic only, not parametric. And if you remember, the graphic is set frequency and set Q. So let me show you a trick that you can do if you want to kind of, how should I put it, lock the EQ bands that you're using. If you go to EQ filters here, you have all the filters and everything, yeah? Let me clear it, because this is where we end up with parametric. And what you do is you choose, so in this case it's going to be all 20 PK, PK, PK. I'm not going to do it everything, but imagine you do all PK, and basically you choose the frequency. So what I did twice. Once I did because you can fit only 20 bands, and this graphical has 31 bands. So since I'm doing like a front two-way, front passive, I need it only from 50 hertz, something like that. So I need it only from band 5. So from band 5 up to band 25, I can use the 20 bands of EQ. And then I'm going to show you, and then from 25 to 31, I'm going to do another one. So what is this one and another one? So you do this, you do all of them PK, 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 and then in frequency, you enter the frequencies. So for example, if I start from 50, I put 50, then the second one is 63, which is 63, then the second one is 80, 80, and imagine you do all of them. You do like whatever it is, 100, 125, 160, 200, 250. It's like a lot of manual labor, but it's going to be worth it. So you do this, and then in Q you put 4.32, and basically you do all the Q bands 4.32, and you have like just in this all the 20 bands with different frequencies, which matching your graphic frequencies, and exactly the same Q of 4.3, and gain is 0. Then when you have this done manually, you save this with this button. You save it, and it saves it as, and that's note, it saves this as a REQ file. So I have 3 of these files. So let me clear this, and I'm going to open one of those files. I'm going to show you. Open. And I have 3 files. So one file is from 50 to 4K, which is for the mid bass. Then from 4K to 20K is for the tweeter. And then from 20 to 160 in frequency for the subwoofer. So let me open this, graphic from 50 to 4, open, and I have this. So basically this is what you entered manually, what I entered manually. It takes like 5, 6, maybe 10 minutes if you're slow, but basically you enter this, and these are your bands that you're telling REW to use. So like, listen, REW, I have only these frequencies and only this Q, and I can use only these. So then you close it, and here in filter tasks, instead of matching response to target, you press on here optimize gains. If I click on that, it optimizes the gains. So basically it keeps all these bands that I entered, and it varies only the gain. So now if I open it, I have all the same bands that I entered, I have all the same Q that I entered, and what REW does, it automatically calculates the gain in order to match your response to target. So from this, I ended up with this. Now the problem with this kinda is that it's kind of blind and it boosts everything. So like this, it boosted up by like probably 10 dB. So let's have a look. 2K, which is band number 17. Band number 17, it boosted by 10 dB. So like with this, you need to be very careful and just to double check. So this one, since I know that this is a reflection from glass, ideally you wouldn't want to boost it, so you disable that band and just keep it disabled, and then maybe pull up the neighboring number 16 a bit up, and just be careful. Same like this one, the 400 hertz band, which is number 10, which is here. So this, as I mentioned, in my case, it's mismatch between the timing of the mid bass and the mid range, and it boosted that one. So ideally you should want to disable that band as well. But anyway, when you, it's going to be a bad example, but let's keep everything. So you keep all of these bands, and then you go to your head unit, DSP or whatever, and the only thing that you need to do is you need to enter these gains. So like if I start at 50, which is this one, so minus 5.1, tab, it jumps to the next one, then the next one is minus 8.5, which is this one, then tab, and so on and so on and so on, and you enter all of them. When you enter all of them, you take a measurement, another one, and that's exactly what I did. So let me show you. So left EQ1. So EQ1 was this one. Man, it's such a same color. It's very difficult to see and differentiate. Let's put it reddish. There we go. So you see it adjusted. Let's remove this one. Yeah. So adjusted everything all the way up to 4K, because those bands, it's only 20 bands from 50 hertz to 4K, and REW can do only 20, cannot do 30 bands. So then I took this one, the measured, which is number 8, I went to EQ again, and then I made another file, which I'm gonna clear it, and I'm gonna open. I made another file that goes from 4K to 20K, which is the last 5 or 6 bands or whatever. I'm gonna open this, and I have 8 bands. Yeah, so I left the 4K just to overlap, and all the way up to 20K. Now again, I close it, and now you see this response. And now if I press optimize gains, it brings everything from 4K all the way up to 20K, all of this area. So you have to do it basically twice, because again, as I mentioned, there's only 20 bands that REW can store. So first 20 bands for the whole thing, and then another 8 or whatever. So you can do that if you have graphical for like different channels. If you're fully active, let's say every driver has a separate channel, but you're limited to graphical EQ, you can limit, like if you're doing mid bass, you can limit the EQ from like 40, 50 up to 1K only. Then for the mid range, you do like from 400 up to like 6K, and so on and so on. But basically you go to filters, You enter the frequency manually, you enter the Q manually, and then you save that file. Yeah? And I did exactly the same for the subwoofer. So, from this one, left one, this is after the first pass of EQ, which goes from 50 up to 4K, which ended up with this. And then the second pass, it fixes the top end with the last bands. And this was my left side. So this one, I think I left it, or I removed the EQ band, but basically I tried not to boost this by 10 dB because it's a reflection from the glass, so you don't want that. But as you see, like if I apply some smoothing, like let's go for 1/3, because why not? 1/3. As you can see, the response is relatively flat for passive crossovers. However, as I said, it boosted the to 400 hertz range, which I'm going to come back to. So this is the left one. The right one, something very similar. So this was the right one. This is my target. And where's the right one? Right, EQ1. Again, it fixed everything from 50 all the way up to 4K. Just like that. And then with the second pass, it fixed the top end, which is as this. And basically I ended up with, where is it? Left EQ2, right EQ2, like this. So then I saw that the level is different, so I needed to bring down the left side by minus 3.8 dB. And I did this by, first of all, I smoothed it. I did show this before, but I'm going to show it again. Smooth it 1-1, highest smoothing, measurement actions, and I'm going to take the number, which one is it? Number 9. And I'm going to go down until they're going to match, which is something like this. Yeah, perfect match. And I see that minus 3.8. So if I enter minus 3.8 in the DSP, on the left channel, which is this one, I'm going to put here minus 3.8. Anyway, yeah, you just put minus 3.8, and then I take another measurement, and then, so that's the left one, left minus 3.8, which is this one. Let's remove the smoothing to see it better. And yeah, so basically now they're level matched. And again, it boosted this part. I will come back to this in a second. But as you see, they match very, very, very nice together. So these are the passive front. Now the subwoofer. Subwoofer without nothing. As you can see, all of this jaggedness. So when I was working with this, what I had to do, I had to apply some smoothing because that jaggedness just messes everything up. So I think I went with 112 or 160 even, just like that. Then I chose a crossover with some experimentation, XO, just to match the target, just like that. And I ended up with a crossover. I don't actually remember what crossover was it, but I was just playing with it. So again, I can actually show you. This, let's swap it for subwoofer. Then I'm gonna take number 4, EQ. Oh yeah, I have it here, number 2. So the crossover was Linquist Riley 24 dB at 58 hertz. So I have matching slope here, and this I can remove with the EQ. So this is exactly what I did. So I have just a little peak here, and I did exactly the same with this. So what I did is number 13, EQ. Yeah, so I have these, again, filters, if I remove them, just like that. And then I saved that preset from 20 hertz to 160, which gives me 10 bands, like here, from 20 all the way up to 160, which is 10 bands. So 10 bands, and If you're wondering what's the noise, it started to rain. I'm in my car. So I have this response. I have like target here, and then I do optimize gains, and there we go. So yeah, sometimes it does that. It just boosts it randomly. So you can go manually and just remove it. Band number 2. Well, anyway, last time I did it better than this, probably because of the level. But yeah, you do it like this, and I ended up with sub EQ, just like this. Yeah. So this is my subwoofer, this is my right, and this is my left. So then after this, and I have this, then I know that I need to phase align the drivers. So in order to phase align them, I used a home impulse and my Scarlett interface with XLR microphone and a loop back. So I do have a video about this. You can watch it, you find it, home impulse. And I ended up with something like this. So I have phase matching at the bottom end. It matches, I want to say, perfect. What I had to do is the left side, the left base was like my reference. The right base needed about 1.3 milliseconds of delay added, and the subwoofer needed 2.4 milliseconds and to invert the polarity, and ended up with matching phase and being in time. As you can see at the top end, at the higher frequencies, the phase kind of shifts, and this is expected because everything is on passives. So the only thing that I can time align is the mid bass to the subwoofer, which is this region. Like everything else, the mid range and the tweeter, they're not phase aligned and they're not time aligned, and they cannot be because they're on the passives. So basically everything above, everything below 200 hertz is perfectly aligned in time and in phase. Everything above 200 hertz is a bit of a mess because so with passives, that's a limitation. You cannot. So after the time alignment, I measured left and right together and ended up like this. And as you can see, it goes nice. Then there's a dip here and there's a little dip here, just because, again, the mid bass and the mid range, they're not in time, and you cannot fix this. No way. Even with all pass filters, you cannot fix it. The only way to fix this is to have the mid range and the tweeters on dedicated channels and go fully active. The other way would be to change the locations of them and somehow, I don't know, just look for different install locations so that they would have same distances like the mid bass driver, like would be on the same plane. Because for me now, I have the mid range is the furthest and the tweeters are a bit closer, and I think the mid bass is closest. But yeah, you cannot do anything about this. So subwoofer, mid bass, and I had to reduce the both of the front passives because I had too much level and not enough on the subwoofer. So in order for them to follow the actual target curve for this, because you can see the subwoofer follows it, and when they sum the front end, it's too loud. So I had to remove 5 dB level, minus 5 dB. And after that, it goes down like this, and when you play them together, they sum perfectly because they're in phase, so they cannot be any other way, just like that. Very, very nice summing. And as you can see, the bottom end is a bit jaggedy jag. So if I remove this, and I apply smoothing, let's say 1/3, just to look better. And where's my target overall? Something like this. So you can see now the color is again exactly the same. Oh my god. There we go. So yeah, So this is a dip because of the cancellation from the front window, from the windshield. And this dip is caused by the time mismatch between the mid-range and the mid-bass. But it's good. It looks good. As you can see, these tweeters don't play high, but it is what it is. And yeah, so this is the whole tuning process. And the main thing to remember is, as I showed you in the EQ window, you can save your EQ bands in order to use everything as graphical as this. So since I'm in my car, I'm gonna give you very quick impressions about this, how it sounds like. Okay, so it is dark, and I do apologize for this, but it's evening, you know. Everyone is sleeping in the house. I didn't want to wake them up. Anyway, I listened to the system for today. I was going to work and back, so it's like an hour and a half spent listening to music. I did listen only on Bluetooth, and this is the main thing. Like with all my these tests and listenings, is that I want to use this piece of equipment as 99% of people would use it, because extremely few are using it like with coax and like high bitrate streaming and that kind of stuff. Most of the people is just YouTube or Spotify and just listen. And this is exactly what I did. Bluetooth, Spotify, and just listen and hear it. So, spectral balance, spectral wise, it sounds amazing. And if you remember the last time when I gave my impressions about like fully passive system, so comparing now, um, spectral balance is better, especially in the top end. It sounds a bit nicer. But the main thing is the subwoofer now is upfront on the dash with the music. Previously, if you remember, I mentioned that the subwoofer felt like it's separate, it's like it's disconnected, and you can locate it. Now, after the phase alignment, it's right there on top of the dash, and it doesn't move. It's just perfect. So the time alignment, the phase alignment did wonders. However, there's some drawbacks to this passive system. The main thing is that you cannot time align mid-range and tweeters. You can only like time align the mid bass to the subwoofer, as I mentioned. So the actual center is kind of there, but it's blurry. Just because like mid-range and tweeters, in my case, there's like a distance of 4 or 5 inches between them, and it's not fixed by time. And the same between mid-range and mid-bass and stuff. So you cannot fix it unless you're going to go fully active. So what I try to do is, after I level match them for the microphone to be perfectly like even within 1 dB. However, I had to reduce the right side by like 2 or 3 dB just to shift the center tiny bit into where it's supposed to be, because the level was just a bit different. And again, the imaging is there, but it's not as precise, it's not as pinpoint. So this is like about the whole tune. It's a success. It sounds great. It sounds much better than on fully passives. But the DSP, oh, okay. So this is the recoil, yeah, the one that measured the worst. And I did mention like previously, that it has some like wiggly things at the bottom end, and you can kind of hear it, that the bass is not as precise as I'm used to it, because this subwoofer, I listened to it before, I know how it sounds, I know how it should sound on a good DSP, and now you can feel that it's not the same. So the bottom end on this Hero Recoil DSP, it's not that great. Another thing, I was listening through Bluetooth, and now like on the phone, when you increase the volume on Bluetooth, you have like on the top bar whatever, and you can like every click it goes up, and like on my phone, I don't know about yours, you go like 60% up, and after that you have like the last clicks are kind of in red. So on the other DSPs that I had, it didn't make a difference on the headphones, I cannot feel the difference. With this DSP, if I go into the red zone, which is like above 60% of the total volume on my phone through Bluetooth, it starts to clip. And it's such a nasty, nasty clip. It's like almost like lightning, like crackling. It's so bad because the volume obviously is high, and it's such a bad clipping. I've never experienced such a bad clipping before. It clips very bad, this DSP. And another thing, when you increase the volume, normally you increase the volume like the clicking the buttons, the volume increases gradually. With this DSP, I don't know why, you do 4 clicks with the volume up, which is like maybe like 20% or something, you get almost the max volume. And after that, all the way up to middle and all the way up, it doesn't change much, like the volume wise. It looks like it's throttling. I don't know how to better describe it, but basically, all the volume is in the first 4 or 5 clicks, and after that, the other 15 or 20 clicks, however we have left, it doesn't change the volume much, but it introduces clipping, which is annoying and weird. And I did notice it when I was actually tuning with pink noise, because I played pink noise through my phone. 1 click, just 1 click, was enough for like normal measuring. 2 clicks were loud, was like maybe 85 dB already. And after that, it's just kind of plateaus the volume, which is, I don't know. I thought maybe it has to do something with the gains, but then like on my amplifier, all the gains are down, like minimum gains. I turn them all the way down. So I know it's not the amplifier that is clipping, because that amplifier, I used it before. I pushed it really hard. I know what it's capable of, and I don't get that volume out of the whole system. And this is like the disappointing part. So this DSP is supposed to do 9 volts, which it obviously doesn't. It does like 1 volt on Bluetooth, because with the actual full system volume that I'm getting before clipping is way lower than I used to have previously. Even with the Alpine DSP amplifier, on the Alpine amplifier, the inbuilt amplifier, it played louder than it plays now through this. So I guess I will need to double check the output of this DSP, but I'm guessing 1.2 volts max. And with this clipping, when I heard that clipping first, I got very scared, because it's like, what the hell is happening? So I thought it may be the boost that I did in the what REW did in like about 400 hertz, a little bit on the subwoofer. So what I did, I removed all the boost just to check, just to make sure that all my EQ bands don't go above 0. So I removed all of them, and it still clipped exactly the same. So the clipping is just because it's too much volume on Bluetooth. I don't know, but like this DSP, on 1 click or 2 clicks, it sounds good. Like the spectral balance, everything, it sounds like it should. It sounds good. But the more you increase the volume, the worse it gets, and the clipping is so nasty, so nasty. I don't want to hear it again. So I'm gonna take this DSP out as soon as possible. I'm gonna take it out, and I'm gonna put something good instead of it. But yeah. So, I hope this whole REW thing with graphical EQ and saving things helped you somewhat. And yeah, thank you very much for watching, guys, and I will see you in the next one.